Welcome to another example of time value of money, where we will look at how to find out future value of an uneven cash flow. Consider that an investor is going to receive rupees 100, 200, 200, 200, 200, 0 and 1000 respectively at the end of 1 through 7 years. Considering that each of these amounts will be redeposited at 6% interest per annum till the end of the 7th year, find out the total amount expected at the end of the 7th year. So as you can see, the cash flow is uneven because it has different amounts: 100, 200, 0 and 1000. So let us first draw the time scale to understand this better. So the tenure is 7 years. So 1, 2, 3, 4, 5, 6 and 7. The rate of interest is 6%. The amount that we are going to receive is 100, 200, 200, 200, 200, 0 and 1000 rupees. And we want to find out the future value of this cash flow. So let us look at some different methods of solving this problem. The first method that we are going to look at is using the formula for compounding or discounting. In this method, the future value, sometimes also called the terminal value, is found by compounding each payment to the end of the stream and then summing the future values. So basically this 100 rupees, we can find out what will be the value at the end of 7 years for this amount of money at 6% interest per annum. We can call this FV1. Next we can take this 200 rupees and see what that will amount to at the end of 7th year. We can call this FV2 and so on. And all these FV1, FV2, FV3 and so on will add up to the future value of this cash flow. So future value will be equal to FV1 plus FV2 plus FV3 plus FV4 plus FV5 plus FV6 plus FV7. Now each of these cash flows create a case for compound interest. So the formula for compound interest is A is equal to P into 1 plus I to the power n. This can also be written as future value is equal to present value into 1 plus I to the power n. Here I is the interest per compounding period, n is the number of compounding periods, PV is the present value and FV is the future value. So if we write the same thing into this formula, we'll get FV1 PV1 into 1 plus I to the power n1. I'm calling this n1 because each of these future values will have a different tenure for which they are being compounded. So this 100 rupees will be compounded for 1, 2, 3, 4, 5 and 6 years, whereas this 200 rupees will be compounded for 1, 2, 3, 4 and 5 years and so on. So for FV2 we'll have PV2 into 1 plus I to the power n2 plus and so on, and then FV7 will be PV7 into 1 plus I to the power n7. So let's plug in these values. So this is equal to PV1 is 100, So 100 into 1 plus 0.06 to the power 6. 6 because this amount is being compounded for 6 years. 1, 2, 3, 4, 5 and 6 years. Plus, now PV2 is 200. So 200 into, now 1 plus 0.06 I'll directly add, so 1.06, and N2 will be 5 plus 200 into 1.06 to the power 4 plus 200 into 1.06 to the power 3 plus 200 into 1.06 to the power 2 plus 0 into 1.06 to the power 1 plus 1000 into 1.06 to the power 0. Now 1.06 to the power 0 will be 1. So let us calculate this amount. So 1.06 to the power 6 into 100 plus 1.06 to the power 5 into 200 plus 1.06 to the power 4 into 200 plus 1.06 cube into 200 plus 1.06 square into 200 plus, now 0 into 1.06 will be 0, and 1000 into 1 is 1000. So the answer is 2124.92 rupees. So basically, if we invest this uneven cash flow stream as and when we receive them at 6% interest per annum, then all of this will amount to 2124.92 rupees at the end of the 7th year. The second method that we are going to see is using the formula for future value of an ordinary annuity. Now, if we look at this uneven cash flow, we see that from years 2 through 5, we have a constant equal stream of payments, which is 200, 200, 200, 200. So this part can be treated as an annuity. So we can take this portion out of this time scale and consider this as 0, 1, 2, 3 and 4. So the time scale is like this: 0, 1, 2, 3 and 4, and the payments are 200, 200, 200 and 200. So if we consider this time scale, then since these 200 payments are at the end of the year, we can treat this as an ordinary annuity and calculate the future value up to this point. So basically we'll get the future value of this stream of cash flows up to this point here. Now once we get the future value up to this point here, we can then find out the future value up to here for this amount. Let's say this is FVA. So this is FVA. Now this then will become FV1 once we find out the future value up to the 7th year. Then we have this 100 rupees, which we can find out the future value. Let's say this is FV, let's call this as FV1 and this as FV2, just to avoid any confusion. And then this 0 will become FV3 and this 1000 is basically FV4. So let's first find out the future value of this annuity. Now the formula for finding out the future value of an ordinary annuity is FV, in this case it is A, is equal to A into bracket 1 plus I to the power n minus 1 divided by I. So this is equal to, now the annuity amount is 200 rupees, so 200 into 1 plus 0.06, so 1.06. The tenure is 1, 2, 3, 4 years, so 4 minus 1 divided by I, which is 0.06. So 1.06 x to the power y 4 minus 1 divided by 0.06 into 200. So this is 874.92 rupees. So we have found the value of FVA, and this is the value at the 5th year or end of the 5th year. So now we have 4 cash flows. One is this 100 rupees. Second is this FVA, which we just found out to be 874.92 rupees. Third is this 0 rupees, and the fourth is this 1000 rupees. So now we have to find out the future value of these 4 at the end of the 7th year. So I have noted the value of FVA here, 874.92 rupees. Now a point to be noted is that this FVA value is the future value of this annuity at the end of the 5th year. However, while we are calculating the value of this amount at the end of 7th year, this FVA will become the present value. So let's call this PV2 because this will get converted into FV2. Now the value for 6th year, let's call this FV6 just for the ease of understanding and clarity. And this at the end of 7th year, this cash flow, let's call this future value 7. So now the total future value is equal to FV1, which is this 100, plus FV2, which is this one here for the annuity amount, plus FV6 plus FV7. Now we know that future value is equal to present value into 1 plus I to the power n. So FV1 will become PV1 into 1 plus I to the power n1 plus PV2 into 1 plus I to the power n2 plus PV6 into bracket 1 plus I to the power n3 plus PV7 into 1 plus I to the power n4. So let us plug in the values. PV1 is 100. 1 plus I is 1 plus 0.06, which is 1.06. And the number of years this is going to be compounded is 1, 2, 3, 4, 5, and 6. So N1 is 6. PV2 is FVA, which is 874.92. into bracket 1.06, and N2, now this amount FVA is going to be compounded for 1 and 2, so 2 years. PV6 is 0 into 1.06, and this is going to be compounded for 1 year, plus PV7 is 1000 into bracket 1.06 to the power n4. Now this is not going to be compounded for any tenure because this is also being received at the end of the 7th year. So this n4 becomes 0. So let's calculate this. So 1.06 to the power 6 into 100 plus 1.06 square into 874.92. Now 0 into anything is 0, so this will be 0. And 1.06 to the power 0 is 1, so 1000 into 1 is 1000. So plus 1000, 2124.91. So this is equal to 2124.91 rupees. Now this is the same answer that we got using method 1. Now let us look at another method. Now the third method is to use the future value factor of a lump sum. Since the cash flows are uneven, we cannot use the future value factors of an annuity. However, each of the payment amounts independently makes a case for using the future value factor of a lump sum. So each of these payment amounts can be considered as a lump sum. So in that case, the future value will be equal to FV1 plus FV2 and so on up to FV7. And as we know, future value is equal to present value into compound value factor of a lump sum. So FV1 is PV1 into compound value factor where n is equal to 6, because this 100 is going to be compounded for the next 6 years, 1, 2, 3, 4, 5 and 6. And I is equal to 6 as well, plus PV2 into compound value factor where n is equal to 5 and I is equal to 6, and so on up to PV7 into compound value factor where n is equal to 0, because this amount is not going to be compounded for any duration, and I is equal to 6. So let us find the values of the compound value factors. So as shown on the screen, this is the compound value factor table of a lump sum. Now in our case, the rate of interest is 6%, which is this here, and the tenure is 1 through 6. So this is the tenure. So the compound value factors are all of these up to here. So let us use these values in our formula. So let's plug in the values. So PV1 is 100 into CVF, n is 6 and I is 6, was 1.4185 plus. So let me write down these values. So these are the values. Now let's calculate this using a scientific calculator. So 100 into 1.4185 plus 200 into 1.3382 plus 200 into 1.2625 plus 200 into 1.1910 plus 200 into 1.1236 plus 1000. So the answer is equal to 2124.91 rupees, which is the same that we got in the previous two methods. Now let us look at a fourth method, which is to use the financial calculator. Now some financial calculators have a net future value key. Now earlier we had seen the net present value key, that is to calculate the present value. But for calculating the future value, we need the net future value key. So if the calculator has this key, then after the cash flows and interest rates have been entered, we can simply click on this button to find out the future value of the uneven cash flow stream. However, even if your calculator does not have the net future value feature, we can use the net present value to find its net future value. So let's understand this. So let's take a case of cash flows. Let's say this is 100, 100 and 100. 0, 1, 2, 3 years. Rate of interest is 5. Now if you have to calculate the net future value, this will be equal to, so 100, 100 and this 100 itself. So the net future value will be equal to, for this first 100, 100 into 1 plus 0.05 square, because this is being compounded for 2 years, plus 100 into 1 plus 0.05 to the power 1 plus 100. So this is equal to 100 into 1.05 square plus 100 into 1.05 plus 100. So 1.05 square into 100 plus 1.05 into 100 plus 100. So 315.25 rupees. So this is the future value or the net future value of this cash flow stream. Now let's use a different method. Let's first find out the net present value and then we will find the net future value. So the net present value will give us a lump sum and then we will find the net future value of this lump sum. So the net present value will be equal to, now for this 100 divided by 1 plus I, which is 0.05 to the power 1, because this has 1 year, plus 100 divided by 1 plus 0.05 to the power 2, because this will be discounted for 2 years, plus 100 divided by 1 plus 0.05 cube. So 100 divided by 1.05 plus 100 divided by 1.05 square plus 100 divided by 1.05 cube. So 100 divided by 1.05. So this is equal to 95.24 plus 1.05 square 1 by x into 100. So this is 90.70. So 90.70 plus 1.05 cube 1 by x into 100. So this is 86.38 and all of this is equal to 95.24 plus 90.7 plus 86.38, 272.32 rupees. So 272.32 rupees when deposited today at 5% interest per annum will allow us to withdraw 100 rupees at the end of the first, second and third years. So this is an equivalent of this cash flow stream at 5% interest per annum. So now this can be used to find out the net future value of this cash flow stream, because the future value of 272.32 rupees at 5% for the next 3 years will be the same as the future value of this cash flow stream. So now the net future value is equal to 272.32 into bracket 1 plus I, so 1 plus 0.05, which is 1.05 to the power n. N is the tenure, so 1, 2, 3. So this is being compounded for 3 years. So 1.05 cube into 272.32, 315.24. So this is 315.24 rupees. So as you can see, these two are pretty much the same. There's slight rounding off error somewhere, but pretty much gives the same answer, as both of these are equivalent to each other. So let us now use this concept in the financial calculator. Now first, in order to find out the net present value of this uneven cash flow, we need to enter the individual cash flows in chronological order into the cash flow register. So in our case, we have CF0, which is equal to 0, and then we'll continue with the cash flow as CFJ. So let's enter the cash flow values. Now CF0 and CFJ are mentioned here, which is enabled by pressing this blue button. So first we have to enter the value. So let's say 0, and then we have to let the calculator know that this is the value for CF0. Next is 100, so 100, and then this is CFJ. Next is 200, this is again CFJ. 200, which is again CFJ. 200 again, this is CFJ. 200 again, this is CFJ. 0, again CFJ, and 1000, which is also CFJ. Now in order to find the net present value, after entering the cash flows, we have to enter the rate of interest, which is 6% in this case. So we click on 6 and then click on I. And now we are ready to click on the NPV button, which is here. So the present value comes out to 1413.19 rupees. So basically the present value is 1413.19 rupees. This is the equivalent of this cash flow as of the beginning of this tenure. Now we'll find out what this amount will get converted into at this point, which is end of the 7th year. So we now have to find out the net future value. Now this is the case of finding out net future value of a lump sum. So in that case, we have to enter 5 key buttons. First is N, which is the number of periods, which in our case is going to be 7. I, which is the rate of interest, which is 6%, so 6. PV, which is 1413.19. Payment, which is PMT, which in this case is 0 because we are only considering the lump sum. And then we have to find out the future value. So 7 is N, 6 is I, 1413.19 is PV, 0 is payment, and now we have to find out the future value. So we'll click on FV. So the future value comes out to be minus 2124.92. The minus sign here indicates that since the present value was positive, that means this is an inflow into our pocket. That means we have taken a loan from a bank or some other organization at 6%. Then the future value, that is at the end of the 7th year, is going to be 2124.92, which we have to pay back to the bank. So that's the only significance of the negative sign. But the value or the net future value comes out to 2124.92 rupees, which is the same that we got in the last 3 other methods. So you can use any of these 4 methods to find out the future value of an uneven cash flow.